Right, so a bit of a departure from the stuff that I've been doing over the past few months. Content, I'm not sure what you call it really, or videos I suppose. I've got to go on a bit of an event in a few days' time, which is going to involve a kind of a bike ride, and we are going to try and lay on some music. So to do that, we've got a bike trailer. We're going to have some. The intention is to have some 12-volt powered musical entertainment to go with our little jolly. Now, I bought this from a good friend ages ago, several years ago, probably about 5 years ago, maybe a bit more, for about 20 quid. And since then it's worked really well, actually, in various locations. I used to use it in our house. When in our previous house we had a kind of a 12-volt like secondary electrical system in the house. I don't know why, looking back. Well, I know why, because we like that sort of thing, and it was good to generate your own electricity and be a bit cleaner and greener, etc. But so as part of that, this was in the lounge actually, and we had a car radio in the lounge, plus this and some speakers, and it was perfectly adequate actually. It was a really good sound system. So it did that for a while, and then since we've moved here, it's been my workshop amplifier. So I've got a computer in the workshop, and I've just hooked that up to this and take a 12-volt feed from the computer monitor. It has a 12-volt output, presumably for powering those small computer speakers that you can get. So similar kind of application. So that's been driving this, and again I've got some speakers up in the top of the workshop, and it's been working really well. Now, so my intention was to use this to run the show, make some music with a car battery in the bike trailer. So I took it down, and the first thing I did was I hooked it up to a car battery with another aspect of this is there'll be a solar panel running the whole thing as well. So I hooked it up to the battery with the solar panel connected to a solar charge controller, also connected to the battery. And curiously enough, whenever I turned this on, the solar charge controller would trip out, which is a bit odd. And this had been happening for quite a long time, and I assumed it was something wrong with the battery. So I assumed that basically the battery was just dead, and it wouldn't deliver the voltage. It wouldn't hold its voltage while it was delivering current to this to run it. So So anyway, so I decided as a test to dispense with the solar charge controller and just connect the battery straight up to the amplifier, because in theory it should just run the amplifier. You don't need a solar charge controller between the battery and the amplifier, unless you are trying to run a kind of solar powered system. So I connected this directly to the battery, and it blew the fuse. So the fuse is a 10 amp, no, not a 10 amp, what is it? I bought a load here, 32 volt. What is it? It is 30 amp fuse was what was in it. So that went pop. So I thought, okay, fair enough. That's a bit odd that it should just go bang like that. But I thought, well, it's fine. It's the fuse is gone. I'll sort of just regroup, take stock, we'll try and work out what's going on, and come back to it in a minute or two. Then there was a pretty big pop and a fizz, and and there was magic smoke. So yeah, so there was a lot of magic smoke came out of this, and which was curious and a bit alarming. So once everything had gone quiet, I disconnected it and took it down. And I mean, you know really that if a piece of electrical equipment is producing sparks and smoke, that it's probably broken. So at that point, I thought, okay, well, I'll take it all apart and I'll have to have a look and see what's going on. So this is the device in question. It is an interesting unit. I've never. It doesn't really have a brand. I've looked online. Google Images has one like this. That is that's up for sale. I think it was an advert on eBay or something, like 20 quid. But that's about as much as I could find. It doesn't really have a brand as such. AMP240, AMP 240. Yeah, so not something that I don't really know who made it. So I have already taken the bottom off it, but I just thought I'd start off with that. So this was the underside, which has got quite an interesting, quite well put together little diagram of all the connections that you need to make. So yeah, it's and the reason, just as an aside, the reason that I've been not struggling, but carrying on with this, is that actually second-hand amplifiers are, I've found, really hard to get. Like normal conventional amplifiers are just really difficult to find. I think they just tend to work, don't they? And they don't really have a huge number of features, so once you've got one that works, you just keep it. So there isn't a really particularly buoyant second-hand market for any kind of amplifier. So when my friend said, "Oh, do you want this?" I kind of said, "Yeah." So I have pulled some of the screws out on the bottom, and because obviously we're going to have to get inside it to see what's what. And this is what I saw, which is basically a whole bunch of the usual electro gubbins that you find inside pieces of consumer electrical equipment. But again, it's got some quite slightly. It's got some interesting aspects to it that make me think that it's not a completely bottom end piece of kit. For example, so it says it says a MOSFET amplifier, and it does appear that, I don't know if you can see that these that the amplification and other cheaper amplifiers I've seen, that they have these kind of chunky monolithic ICs with like 30 pins that kind of stand up that do the amplification. They're kind of integrated, but this has got what looks like kind of individual MOSFETs, one there, one there, one there, and one there, one there, one there, one there, and one there, that's actually doing the work, which I think to me is a slightly higher quality solution. I would have thought they're all heat sinked. They're clamped down and heat sinked to the chassis. It looks like there's some thermal paste down there, and which is actually, this is a really quite solidly machined piece of it was anodized, isn't it? It's like a really chunky piece of aluminium. So with these kind of fins on top, so there's quite a lot of kind of mass of metal for the heat to sink into before it then gets dissipated. And lastly, I think the caps are really good, quite good ones. The ones that I can see are Rubicon. So there's Rubicon capacitors. These two are Rubicon capacitors, and these ones are Nichicon capacitors. Nichiden capacitors. But I think they're not like no-name bottom end caps. So so I suppose the long and the short of it is that I think, from the looks of it, this is actually worth repairing. So as to what happened, I've got a theory, just see if I can get the right bit of the board in shot. It's a bit hard to see. So my guess in the power supply end of the device, there is in here, which you can't see very easily, there is a capacitor, an electrolytic capacitor across the B plus and B minus, or 0 volts, the ground and B plus, let's say. Entirely upstream of the fuse, there are two caps. There's one that's a kind of ceramic, and there's one that's an electrolytic. So whatever happens, that's always going to have a voltage across it. Okay, so I just had a full memory card moment, but I think I was talking about just what I thought had happened. So yeah, let me just come in here again. Can I get the light there? So we've got, I might have to use a pointer, or a screwdriver will do. Yeah, okay, so I think I was talking about this. So basically we've got an electrolytic cap here, always across the battery, a ceramic cap, this ballon looking thing, a fuse, and then downstream of the fuse there's another quite big quite large capacity electrolytic capacitor here. So in my head, I think what has been going on, I think what's been going on is that this, I think, now which one do I think it is that went first? I think this capacitor maybe was starting to leak. Okay. Now when the amplifier was attached to the monitor, I reckon that was current limited in its supply, so the amplifier could kind of survive, and we wouldn't get into the territory we got into later, but essentially the monitor would provide 12-ish volts across here, and but the current that could be drawn was kind of maxed out at a certain level. I remember the amplifier, I think I felt like it had started to stop performing very well, and we had to crank it to quite a high volume to actually get much out of it. And if this was leaking, and therefore the voltage was kind of lower than it should be throughout the rest of the circuit, then that would be kind of aligned with that. But so when I then connected it to the solar charge controller, again the leakiness of this, I think the battery was basically leaking, trying to leak across through here. That was dropping the voltage coming in, such that the solar charge controller was tripping out and cutting the battery off, because that's what, if you try and run the battery down to too low a voltage, it cuts off, and that again was protecting the system, so it wasn't getting into the final catastrophic failure that it did. When I ultimately connected it directly to the car battery, I think what happened was the leakiness of this capacitor caused an excessive current to be drawn through the fuse, which then blew. Okay, but having blown, it then left this capacitor here, down here, with the full might of my car battery across it. It then, I assume, was leaking as well, and essentially acting as a resistance, got warm, and then went into a runaway catastrophic failure where the electrolyte basically just boiled off and the whole thing went fizz bang. Okay, that would explain why. So this capacitor doesn't look like it's actually blown itself open, and I think that was because it was protected either by the power supply of the monitor, or the solar charge controller, or the fuse that eventually blew before this could let go. This one here, once that capacitor was out of circuit and leaking and in a sense protecting this one from full voltage, once this fuse had gone, that capacitor in there was exposed to the full voltage and eventually just blew out. So that's what I think happened. But so what I've resolved to do is, I'm not sure, I'm not really going to diagnose things particularly. I'm going to make the assumption that everything downstream of this kind of power supply side is basically okay. I'm going to replace this capacitor here, this one in here, and these two big ones here. I'm going to replace the big ones. I think if that actually makes the thing work, after I've used it for this ride, I've bought some of the kind of second biggest ones. These electrolytics down here, I'm going to change those out. Ultimately, I should probably recap the whole thing, but my priority right now is to just try and get it back into service. So that's what we will do. So there are a whole bunch of screws to take out, which I will do now. I have pre-loosened them a little bit just to make life easier for myself. I will confess. I'll get this. I'll do that probably on a time-lapse type thing. I don't know if I can change this on the fly, but I'll just whiz all the screws out, trying to keep track of which screws go where, and then we'll take it from there. Right, so I've got all the screws out that I can see. It makes me think of these guys that just, on these other YouTube guys that just rip stuff apart without any, without really seemingly keeping any track of where they're taking all the bits out from. It kind of worries me where blokes pulling carburetors apart and just all these tiny bits and just throwing them into a bowl. I've tried to keep all my I've tried to be reasonably rigorous and keep all my bits in separate bags, and that should help me to see see what's what. So yeah. Yeah, so it looks like I've got all the screws out. It is quite well made, this thing. It's not only have they screwed everything down, but they've strategically glued bits as well. So I'm just trying to, and the board has kind of been bonded into the case. There we go. Right, there we go. She's free. Okay, there we go. Right. Right. So just trying to see what we've got here. See if it's obvious where all the magic smoke came from. I can't see anything too scary on the underneath of the board. Slightly odd is the fact that these is it odd? No, so what's going on here, I think, is that the MOSFETs have got kind of a rubber pad underneath them between I suspect is that insulating them from the case? It just seems a little bit counterintuitive, because the idea is to conduct as much heat as possible to the case, I would have thought, but presumably this is insulating material that actually will allow them to transfer some heat as well. I might leave those be, to be honest. I was going to replace the heat sink paste on them, but I'm not sure whether I want to faff with them, just in case I accidentally short it. So what are we doing here? What do we think has failed? So AVOX, that is an AVOX capacitor. Has that come unstuck? This capacitor here is the one that I was thinking had blown itself apart. Yeah, actually, I think you can see, but I think that the cap, the end of the cap there, I think that's pretty bulged out, and I think that's blown. I think that is what's gone. But I reckon I reckon this one here, I think that must have been suspect as well, because there would need to be, surely there'd need to be an excessive current going through the fuse to actually blow the fuse. This capacitor failing here wouldn't blow the fuse, I don't think, because it is directly connected across the B plus and the ground. So I don't think that was the thing that initially started the chain reaction, the chain of events. I think this one here is dodgy, and that kind of cascaded through to this one here and caused it to fail. So I suppose I'm going to have to, oh dear, that looks pretty ugly. I suppose I'm going to have to try to get both of those off. I can probably clip that one. That one is curiously enough kind of floating in space, so maybe I should clip that off and then just pop a new one in. This one here is going to be a bit more problematic because it seems to have a huge blob of solder around it, although there we go, maybe we'll be alright. C301. Right, let me see if I can, I haven't got one of these fancy desoldering guns, so let me see if I can do this with my own fairly meagre resources. I'll just have a look. I'll get my soldering iron warmed up. Oh no. I'll get my soldering iron warmed up and then we can take it from there. Soldering iron on. Not wanting to embarrass myself by oh come on, focus. Hello? No. Well, I wasn't going to embarrass myself by showing you me wrestling to get this capacitor out of the board, but it is out. Rubicon 20. Can you read that? Yeah, I'm struggling to get my camera to focus. It's struggling a bit. Come on. 25 volts, 1000 microfarad capacitor. Outwardly not looking too bad. It doesn't look like it's. It could well be leaking, but maybe it's not showing it externally. I'm curious to see. So I appreciate capacitors are complicated beasts. They don't necessarily do what you think they should. In terms of a leaky capacitor may not simply act as a resistance. There's all sorts of special behaviours and measurements that you can take, and a proper capacitor tester is a very particular piece of kit. But let's see what the resistance is across it. Just the basic resistance. Is this making any sense? I don't know. So that's open, fine. Let's see what, just compare. So I'm just going to compare the old capacitor. What do we get? It's saying open. Saying open. What about this one? What do we get if we put, this should say open as well, I think. Interesting. 4.1 megs, but dropping fast. So is that it charging up? What do I get if I touch these together? If this is a dead short, 0.02, 0.01. Okay. If I have them completely separated in space, I get open. If I put the probes across this supposedly dead capacitor, right, so I'm getting 20 meg, 17 meg, 15, 17, 16, okay. So that's saying 15 megohms. And this one is saying 4 megohms. Oh, that's curious. That wasn't really what I was expecting. Oh, pants. No, I've lost it. Oh, there it is. That wasn't what I was expecting, but as I say, capacitors are complicated. If you want to learn about capacitors, go to Mr. Carlson's lab. He will tell you what's what. Oh, hang on. Not megs. Oh. No, and he'll laugh at me for doing something really stupid. I wonder what this... It does have something that says Capacitor Tester on it. I wonder what this will do. So if I connect up the capacitor... Right, so that is saying 1 MF. 1 MF, that's saying microfarad. What does this say? So this is supposed to be 1,000. Oh yes, it's 1,000 microfarads. So this capacitor here, according to the multimeter, this capacitor is basically behaving as it should. But that's kind of exactly the sort of thing that I think is exactly the sort of thing that can catch you out. Okay, well, what I'll do, I'll pop this in. I say pop this in, bloody hell. It's going to be more difficult than that. There's a huge glob of solder all over where it's supposed to go in. I can't really see any holes at the moment. So I have to I think I'm going to have to melt my way into the solder and actually push this through gradually, which will be inelegant and unprofessional looking, so I'll probably turn you off for a bit while I put this one in. So I'll put this new cap in there anyway, and then I'll replace the other cap, and then actually, to be honest, we're done, and at that point we can see if the thing works, and take it from there. Right. New capacitor in place. There. Got the legs sticking out. You can see it's a really rather kind of globby field of solder that this went into. It's not so yeah, I was expecting it to be a lot more difficult than that, but I seem to have managed to get it in. You can just see the leg there sticking out. I've got to work on trying to get better camera angles. So anyway, that is the first time I've ever replaced a capacitor for the purposes of repairing a thing ever in my life. So there you go. I've watched about 40,000 hours of YouTube of people putting new capacitors into out-of-date computer equipment. So I feel like I've feels like a rite of passage. So I just clip the legs off. I tend to hang on to the clipped off legs of stuff like that because they're quite thick and they're quite good for making sort of bridging things in circuits, and because I tend to still build stuff on Vero board, you know, like the strip board stuff, which is super ridiculously overcomplicated and stupid, to be honest. Now there are outfits that will actually make PCBs for you and post them back to you. I should probably stop doing that, start trying to design my own PCBs, but I'm nowhere near that level of electronics at the moment anyway. So the next one to get rid of, which I think is definitely a blown capacitor, is this one here. It's got so much. Oh God, I really need to get better light. Can I? Yeah, that one there. So this one is a 220 microfarad, 50 volts. I'm not sure how easy this is going to be to do because it's kind of floating. It's kind of a point-to-point type job. I can give it a try. I just don't want to desolder everything else while I do it. That's all. Can I get in there? Do you even want to watch this? It's going to be ugly. It's not going to be great. It's going to be me sort of burning my fingers. There's such a huge blob of solder on there that you're going to have to be pouring heat into it to get it to melt. You know what, I think I'm going to clip, this doesn't feel right, but I think I'm going to clip the legs off it. And see if I can solder a new one in. Maybe kind of using the old legs to allow me to get in there, to allow me to actually solder. So this, yeah, something's come out of it. So I'm just out of idle curiosity, I'm wondering what this would look like if I measure the resistance across it. .6 megs. And if I get the new one, I'll get the new one out. Let's see what we got there. Resistance. .5 megs. Right, capacitance. Let's see what the it says the capacitance is. 196 microfarads. And what's the capacitance of this one? The old broken one. 197. Okay. I think I need a proper capacitor tester because I don't think using a multimeter is really gonna help us. So B plus. So we want the positive going over is to go to the B plus side, and the negative is going to go to the other side. So I think I'm going to stop there and just try and get this soldered in because it's not going to be pretty to watch. Okay, so it's done pretty nastily. Can I get this in shot? Where are we? There. Okay, this is what I've done. So the amount of solder that was used to connect the negative rail of the board to the negative input. It was huge, and similarly on the positive side, there's a huge blob, and my soldering iron just doesn't have enough energy to pour into that to melt it. There's also a hell of a lot of metal here, and it was just all the heat was being sunk away. So this is probably not best practice, but I clipped off the legs of the old capacitor and basically soldered the new capacitor onto the stub of the leg of the old one. There you go. If any of my 8 subscribers want to comment on that, then go ahead. I know one of them's my mum, and she probably doesn't have much of an opinion on it. Sue me if it's not a good thing, but it worked. I think we've got a good connection there, so that's good enough for me. So what I'm going to try and do now is hook it up to some power and see if we actually have a working amplifier back, or just another blown fuse. Alright, let's see. So let's connect it up. So this is coming off the solar charge controller. So in this instance, I think the solar charge controller should protect it and drop out if we're getting excessive leakage, which I really hope we're not. But okay, I'm going to touch this in now. See what happens. Oh dear. Maybe not. Interesting. We're not getting a total. So the charge controller's gone to amber status, interestingly, which means before I was getting the full flashing red, green and yellows, which means that the battery's defunct, but that is interesting. We're getting amber, which means the battery's not quite losing voltage so much. So just wondering if we're getting so we're not getting a power light at the moment. Now to get the power light, I need to bridge across these two. I think I need to bridge across 2 terminals there. There is a remote terminal there that basically when that's connected, that is what starts the thing up. So I need a bit of wire. I have loads of wire. I just need a bit just to bridge that. Can I find a bridging piece? Should I just do it with a screwdriver? Let me see what happens if I bridge across between the B plus and the... I can't. They're stopping me from doing it quite sensibly because there's a piece of plastic in the way. Hold on, let me just see if I can find something to do that with. So I've bridged across that. And if I can move this without causing a major explosion, we now have power. A power light, which is good. Nothing's caught fire yet. No explosions. The battery status. Tripod. Battery status now has gone back to green, which is promising. Interesting. I don't understand why, but it seems to have gone back to green. So that looks to me like that is actually working, which is kind of weird, but also good. So I wonder if we can manage to get any sound out of it. I'll need to kind of fudge about with some stuff to get some, see if we can actually drive any speakers, but let's see. I'll bring you back in a second. That applies to... Okay, that idiot you can hear burbling away in the background is actually me. So this is a video I made earlier. But what that means is that this is actually working. I've sort of kind of cobbled it up into my wiring that goes up and then into the light, which is really bright, and then across to the speaker over there, and there's another speaker over here. But I've only got one channel hooked up at the moment because I couldn't be bothered to try the other one to do both. But yeah, anyway, I probably better turn it off before those MOSFETs get too hot actually. So let's just stop that from doing anything at all. There you go. So right, that shouldn't be... I think I can feel heat coming off them actually already. Or am I just imagining it? So anyway, let's probably not a good idea to run it without any heat sinking at all. So there we go. One repaired small amplifier, as far as I can tell. It hasn't tripped out the solar charger, so I would suggest the leakage is has been reduced, and so yeah, all being well, we won't get another catastrophic failure like that for a while, until of course these capacitors reach the same state of dilapidation that the previous ones were. And there we go, look at me, just sort of rabbiting on about the aircraft. Anyway, I'm calling that a win for now. I'm probably going to leave it wired up to the battery overnight and see if the battery takes it through the night, and also just to give it an opportunity to explode before we do the ride. Okay, thanks very much. Yeah, thanks for watching. That was probably pretty boring, but that's the best I can do at the moment. I suppose it just goes to show, well, there's a few things. It just goes to show that you can repair this stuff, okay? If you buy the bits and you kind of know what you think is wrong with it, you can make stuff work. Well, that's good. What else? Other people are a lot better at doing these kind of videos than I am. I've learned that's a key message. And also, people who do electronics who know what they're doing. I never managed not to create all kinds of bird's nests of wires and crap. And I don't know how these people do it. They're so organised. They always have loads of little drawers like that, but like loads more of them, which is obviously what you need. And they also have something that I have bought recently, which is, are they even here? Can I even find them? Vast quantities of little jumper wires. I bought a massive pack of them. Here we go. Yeah, here we go. Them. Electronics. That's electronics. So I need to. I'll probably get some use out of those. But yeah, that's pretty cool. It's still not on fire. Is it on fire? No, it's not on fire. The power light is still illuminated. The solar charge controller is still not telling me that it's losing voltage through current leakage. And I think we've got a working thing. So all I need to do now is put it all back together again tomorrow after I've had some beer. I'm going to have some beer. I feel good. I feel better. I feel good, obviously. Never feel good, but feel better than I did. So yeah, okay, there we go. Call that a win. See you on the next one. Bye.